Today I will be talking about dimensional modeling, star schema, primary key, composite key, foreign key, basically on how to design a data warehouse. Okay, the data warehouse design is based on dimensional modeling. Dimensional modeling supports high volume query access. Dimensional modeling is also implemented via star schema. Okay, a star schema consists of a central fact table surrounded by several dimension tables. Let's revisit what we have learned so far. We are talking about designing a data warehouse. This part is technical. We are talking about designing a data warehouse. A data warehouse design is based on dimensional modeling because the dimensional modeling supports high volume query access. Dimensional modeling is also implemented via star schema. What is a star schema? A star schema is made up of a central fact table which is surrounded by several dimension tables. Now I would talk to you about the fact table now. Remember, there is only one central fact table. The fact table contains a large number of rows that correspond to observed business or facts. So fact tables contain quantitative data about a business. Information that is queried. It's a large table. It contains several rows of data that is quantitative data about a business, and it contains information that are queried. Example of information, example of data in the fact table would be revenue, sales, profit. Look at revenue, look at sales, look at profit. They are quantitative data. And also you query information about these data. You want to find out the revenue the company earned. You want to find out the sales. You want to find out the profit for a particular quarter. Okay, so these are quantitative data which are stored in the fact table, and fact table is a very large table. Now the dimension tables, they surround the fact tables. Okay, what are these dimension tables? Dimension tables are smaller. They hold descriptive data that reflects the dimension of a business. Okay, for the dimensions of a business would be the different types of products, location of the company, information about customer, the time frame, is it weekly, monthly, yearly data. Okay, so these are descriptive data. These are descriptive data that reflects the dimension of a business, and dimension tables are smaller tables. Okay, before I go further, I will give you the difference between a fact table and dimension tables. Consider how an analyst looks at business performance. An analyst looking at business performance. A salesperson analyzes revenue by customer, product, region, and time. A financial analyst tracks profit by product and time period. A marketing person reviews sales by product, region, and time. Okay, so fact table contains quantitative data. It is large. Dimension table contains descriptive data that reflects the dimension of a business such as region, customer, product, time, location. Fact table would contain quantitative data like revenue, sales, profit. So, a star schema would have a central fact table and then it would be surrounded by dimension tables. Now I will talk to you about keys. Those of you who are MIS majors, you know keys. Okay, those of you who are non-MIS people, you need to know what are keys and you need to know correctly. Okay, you should have thorough idea about what are keys. Please listen to this video. After this, if you do not understand what are keys, feel free to drop by or feel free to write to me, call me, because it is important that you understand what are keys. I give you a table. This is a dimension table, okay? I give you a dimension table which I named student. It has descriptive data about a student. It has student ID, student name, student address. Okay? Then for each table, you need to know what is a primary key. Each table has a primary key. I gave you a dimension table here which is about student. Okay? So the table contains descriptive data about student. Student ID, student name, student address. What is a primary key? A primary key is a column of a table that would uniquely identify each row of the table. Okay? For example, student name. I teach 100 students per semester. I can have 5 Jason in my class. Okay? 2 students can share the same address. So they are not unique. What is unique about a student? So that when you come to me and when you ask me for your grade, I can give you only your grade, your ID. Okay? Because your ID is unique. Unique means no 2 people would have the same ID. Okay? So primary key in this example would be student ID. So basically it's a column. Student ID is a column that uniquely identifies each row of the table. Now if you look at the ID, you will see that if you look at the rows of data, you will see that each ID is unique. The first one is 425, the second one is 578, the third one is 876, then 869. So each is unique. So primary key basically is unique. The next thing that I would like you to know is what is a composite primary key. What is a composite primary key? Okay. When more than one columns uniquely identify each row of the table, that's called a composite primary key. Look at this table. This is an ordered product table. I have product ID, I have order ID, and I have quantity. Look at the product ID P1, P1, P2, P2. So this is not unique, right? Because P1 is repeated, P2 is repeated. Look at order ID O1, O2, O1, O3. Order ID is also not unique. It has repeated itself. Okay. So how am I then identify a primary key for a table? If quantity can never be a primary key. Okay. So how can I then, because many of you can ask for the same quantity. When you go to a fast food restaurant, I can ask for 2 coffees, you can ask for 2 coffees too. So quantity can never be the primary key. So in this table, I see that single column is not going to be a primary key because product ID has repeated itself, order ID has also repeated itself. So in that case, what I have to do next is I have to see if the combination works, in the sense that if the combination is unique. So now look at P101, P102, third row, P201, fourth row, P203. So the combination of product ID and order ID is unique. Okay, so I now have a composite primary key for this table, which is product ID plus order ID. So product ID is not unique, order ID is also not unique, but product ID plus order ID together, P101, P102, P201, P203 is unique. So I have a composite primary key for this table. So when I have more than one columns that would uniquely identify each row of the table, I have a composite primary key. This is another example of a student table. Student ID, course ID and grade. Student ID is 13. The course taken is misy 3310. The student ID is 17. Course taken is misy 3310. Student ID is 13 again. Course taken is misy 4350. Now you see student ID is not unique because 13 repeats itself. Course ID is also not unique. 3310 repeats itself. But if you look at it carefully, that student ID plus course ID is unique and it is a composite primary key. What is a foreign key? Foreign keys are used for joining tables. Okay. And if the primary key of one table appears on a second table, it becomes a foreign key in that second table. Okay. Let's look at it this way. Look at the customer table. Customer number, customer name, customer address, customer phone. Since customer name, address and phone can repeat itself, like I can have two customers by the same name. Two customers can be sharing an address, so that's not unique. They can share a phone, so that's not unique either. So customer number is the primary key of the customer table. Okay. Now look at the order table. Order table has order number, order date, order time and customer number. Now order number is the primary key of the order table. Customer number, which is already a primary key of the customer table, if it shows up in another table, it has shown up in another table, it has shown up in order table. If it shows up again, it becomes a foreign key in that table. So what is a foreign key? Foreign key is used for joining tables. And how do you identify a foreign key? If the customer number of one table shows up on a second table, it becomes a foreign key in that table. Look at here, the customer number of the customer table, which is a primary key, has shown up again on the order table. Order table already has a primary key, which is order number. But customer number, which is a primary key of the customer table, has shown up again on the order table. So it is a foreign key in that table. Okay. Now, there are, when you have multiple tables, you have to join the tables from primary to the foreign key, from primary key to the foreign key. This is how we join the tables. The foreign key is always on the many side of the relationship. When you have multiple tables in a database, you have to join the tables. Once again, how do you join them? You join from the primary key to the foreign key. Okay. When you can have one-to-many relationships in a database. What are one-to-many relationships? With respect to the customer, one customer can place many orders. So if I consider these two tables here, the customer table and the order table, these two tables have to be connected. So if I have two tables, the customer table and the order table, then the two tables each should have a primary key. Okay. And then I have to find out the foreign key. So I found out the foreign key. Now when I join the tables, I would join always from the primary to the foreign. Okay, so I will join from the customer key, customer number, which is the primary key of the customer table, and then I would connect it to the customer number, which is the foreign key of the order table. Okay, so when I have a one-to-many relationship, it means that one customer can place many orders and one order can be placed by only one and only one customer. Okay. Now, how to draw a start schema? This is how you draw a start schema. Remember, you have one fact table, and in the fact table, you have the quantitative data, which is sales, profit, and revenue. So I have the fact table, which is called sales. I named it sales table, which is my fact table. It would contain all the quantitative data. So sales, profit, and revenue is in the table. Then I have the dimension tables, which are product, region, and customer. So within the product table, my columns are product ID, product description. Within region, and product ID is the product primary key of the product table. And then I have a customer table, which is a dimension table, which has customer ID and customer name, and customer ID is the primary key. And then I have region, one and pay attention, okay? Then I have the region table, which has the columns region ID, country, state, and city, and region ID is the primary key. Okay, so we are talking about star schema. The star schema will have a central fact table. I call that central fact table, I named it as sales. Okay, it contains the quantitative data, which is sales, profit, and revenue. Then I have the dimension tables, product, customer, and region. Find out the primary keys of each of the dimension table, which are product ID, customer ID, and region ID. Okay. In the fact table, you have to also add the primary keys of the dimension tables. So I have added product ID, region ID, and customer ID. However, they are already primary keys in the dimension table, so they would become foreign key in the fact table. And then I would join from primary to the foreign one to many. This is basically start schema. Once again, in start schema, I have a central fact table which contains quantitative data like sales, profit, revenue. Then it is surrounded by dimension tables which are descriptive data like product, like customer, like region. Also in the fact table, other than the quantitative data, the primary keys of the dimension table get added. So I have product key, product ID, which is a primary key of the product table in the sales table. I have customer ID, which is a primary key of the customer table added to the sales table. I have region ID, which is a primary key of the region table added to the sales table, and all these are foreign keys in this table. Now, I cannot have 4 tables which are not connected. I have to connect the tables. So now I connect from primary to the foreign, one to many. The many is always on the foreign key side. Any question? Okay, now what I would do is I would stop sharing this dimension modeling thing and I would go over assignment 3. Okay, I would go over assignment 3. So you have to bear with me. I will stop sharing this and then I'll pull up assignment 3 file. Okay, for this assignment which is due on February 3, you have to use Microsoft Access. Okay. MIS students, actually all students, because all of you have taken misy 3310. So in 3310, in 1373, you have learned Access. So it would be revisiting Access again. If you have questions on Access, you can go to Aaron Townsend, who is our helper for this class, student assistant for this class. You can come to me, but we would have to know how to work on Access. Okay. So what am I giving you here? This is what the assignment is. I'll walk you over the assignment. I've given you the following information. I've given you the product type, okay, and the product type is coffee, espresso, herbal tea, and tea. I gave you the description of the product. It's Colombian or cafe latte or mint, or tea is Darjeeling, okay. Then I gave you product ID 1, 2, 3, 4. I give you product type, regular, decaf, etc. I give you area code. Area code will give you store location such as 203, 206, 209, so on. Then state, so that you understand the data element. Okay, I give you some examples. State can be Connecticut, Washington, California, Texas. Then I give you the market. Market can be east, west, south. Market size can be small, major. Profit measured in dollars. Margin measured in dollars. Sales measured in dollars. Cost of goods sold measured in dollars. Budget profit measured in dollars. Budget margin measured in dollars. Budget sales measured in dollars. Budget cost of goods sold measured in dollars. What am I asking you? I'm asking you to create the dimension tables. 4 points for that. I would like you to identify the primary keys in each table. Another 4 points. I would like you to create the fact table. Another 4 points for that. Identify the foreign keys in the fact table. So put the foreign keys in the fact table, which are basically the primary keys of the dimension tables. And then join. Create the star schema for the coffee store that will enable the coffee store to analyze its financial health. When I say create the star schema, That means you have to join the primary keys of the dimension tables with the foreign keys of the fact table. Okay, and you also, while you join, you also have to enforce referential integrity. This is your assignment 3. Any question? So all the quantitative data will go to the fact table. Descriptive data will go to several dimension tables. Okay, and then you have to identify the primary keys of the dimension tables, put those primary keys in the fact table as foreign keys, and then you have to join from